This is part 2 of problems using U substitution, so problems that are reducible to quadratic equations. Looking here on the left, we have 4m to the negative 2 minus 3m to the negative 1 power minus 1 equals 0. Again, you might have the instinct to take the reciprocal of these. That's what we do with negative exponents. But before we get into kind of a pickle here, because we have negative 2 power and a negative 1 power, this is not a complex fraction or something to simplify. I notice that negative 2 and negative 1 is half of negative 2. So again, this middle term has half the degree of the first term. So this is reducible to a quadratic equation. I'm going to let u equal the middle term. So m to the negative first. I leave that coefficient alone. I only take the variable. If I square both sides of that equation, I would get u squared equals m to the negative second power. So I have 4m to the negative second minus, scratch that. Getting rid of that negative exponent and replacing it with u squared, and replacing m to the negative first with u. Now my leading coefficient here is not 1, so I have to multiply these two together. So I'm looking for factors of negative 4 that will add to negative 3. So I'm thinking 4 times 1, and I put the negative with the 4. Negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3. Now that leading coefficient is not a 1, so I have to go into my 4 terms here using the factors that we found, and then factor by grouping. The first two, I take out the GCF of 4u. When I divide that out, I'm left with u minus 1. And the second two, the GCF is just 1, so I still have u minus 1. If I did that right, these should match, and they do. So I take out that GCF of u minus 1. What's left is 4u plus 1. So again, these cannot be put right into our factors because that leading coefficient was not a 1. I need to solve both of these by setting them equal to 0. That means that u could equal positive 1, or I would subtract 1 and then divide by 4, so I get negative 1/4. Don't stop. We're not done yet. We're not solving for u, we're solving for m. So I have to replace u. So u equals m to the negative 1 power. So I'm going to replace u with m to the negative 1 power. Now, how do I get rid of a negative 1 power? Well, I don't want m to the negative 1. I want m to the positive 1. So I could just take the negative 1 power of both sides, right? Because negative 1 times negative 1 would give me positive 1. So that's just m now. And negative 1 power takes the reciprocal, but the reciprocal of 1 is just 1. Same thing with the next set. Take it to the negative 1 power, take it to the negative 1 power. Negative 1 times negative 1 is 1, so just m to the first power on the left. On the right-hand side, we have to take the reciprocal. Now, it doesn't change the sign, it's still negative, but the reciprocal of 1/4 is 4 over 1, or just 4. In this case, negative 4. So m could equal 1, or m could equal negative 4. You can check these, and I believe they both work. Go ahead and try the example on the right. Alright, let's see how you did. So looking at this example, we can see we have this whole quantity is being squared. And then that same exact quantity is to the first power. So again, the middle term is half of the degree of that leading term here. And the whole quantity is what's being squared, and that whole quantity is what's to the first power. So we're going to let u equal, again, the middle term. And the middle term is everything in the parentheses, x squared minus 2. And then that means that u squared would be that whole entire quantity squared. So now we can substitute it in, replacing x squared minus 2, that quantity squared, with u squared, and the coefficient stays the same, and replacing x squared minus 2 with u. Now I have a quadratic function. I'm looking for factors that will multiply to 20 and add to negative 12. So I'm thinking they would be 2 and 10. And if I want it to multiply to a positive but add to a negative, they have to both be negative. Since my leading term has a coefficient of 1, I can go right into my parentheses of u minus 2 and u minus 10. Use the zero product property to set each one of those equal to 0. And then solving each one for u. So add 2 and u equals 2, add 10 and u equals 10. Now we weren't solving for u, we're solving for x. So I have to go back to what I let u equal and replace this back in for u. So u equals x squared minus 2. I'm going to replace this with x squared minus 2. X squared minus 2 equals 2, and x squared minus 2 equals 10. We want to get x alone, so I add 2 to both sides. And the left one here, I have x squared equals 4. And on the right, I have x squared equals 12. Now, again, I need to get x alone, so I have to undo that square with the square root property. And I'm not going to forget my plus and minus when I take that square root. So plus and minus, there are two solutions. That means x could equal, the positive square root of 4 is 2, and the negative square root of 4 is negative 2. Or, over here, square root of x squared is x, and I'll have the positive and negative square root of 12. I need to make sure I simplify that radical, break it down into 4 times 3, and 4 is 2 times 2. So there's my square, or my pair that I can take out, and I'll have a positive and negative 2 when I take those out, and I'll be left with square root of 3, so the 3 is under the radical. So overall I have 4 answers, positive 2, negative 2, or the positive square root of, 2 times the square root of 3, or the negative of 2 times the square root of 3. And I have tried all of these, and they do work. So you should be checking all 4 of your solutions, though, when you have problems like these. And there you go.